In this video, we're going to talk about how to rewrite an absolute value equation as a piecewise function. And by the end of this video, you are easily going to be able to take an equation like this and rewrite it as a piecewise function. But before we get into this, I want to show you that on Mathway, you could check your work. So the way you do this is you enter just the absolute value portion of the equation. In other words, you do not write y equals or f of x equals. Then you press enter, and when you're prompted with the menu, you ask them to search for piecewise. And be careful spelling that word, it's not easy. And it'll prompt you with writing the absolute value in a piecewise manner. But just in case you are not allowed to use Mathway on a quiz, for example, I'm going to show you how to do this step by step. First thing I want to do is talk about the intuition of the absolute value function. So if you have a positive result within the absolute value function, the final result is going to be the same as what is inside the absolute value. However, that is not true if you have a negative result inside the absolute value. In this case, the final result and the result within the absolute value are going to be opposite. So we're going to use this fact to help us navigate writing the original absolute value equation as a piecewise function. Let's go back to the problem we discussed earlier, and I'm going to show you two ways to do this. The first way is to take what's inside the absolute value and set that equal to greater than or equal to 0. Solve for x, and you're going to get x is greater than or equal to 2. Now, since I set what was in the absolute value to a positive value, in other words, greater than or equal to 0, we are going to use the same exact function. Because remember, if you have a positive result inside the absolute value sign, you have a final result which is positive. They are the same. Therefore, you use that same function. So the first part of our piecewise function is going to be that for values x greater than or equal to 2, we are going to use the exact same function that we were presented with. Next, we're going to set what is inside the absolute value to less than 0, namely a negative value. Now we're going to get 3x is less than 6 and x is less than 2. Now folks, because we set this to a negative value, okay, let me use red for emphasis. Because we then set this to a negative value, the final result, which is always positive, is going to be opposite. And because of that, we are going to use the opposite of the original function. And again, this is for values of x less than 2. Now, you can leave it in this format, or you can distribute that negative and get negative 3x plus 6. Okay, I'm going to show you how to do this a different way. I don't particularly love it this way, but your teacher may show you how to do it this way, so I'm going to show you. So let's rewrite the original equation. Now here, what some students do, or some teachers do, is they set that equal to 0. And then they get 3x equals 6 and x equals 2. So 2 is the dividing point. So what you would do is you put 2 here, and what I like to do is create 2 zones. All right. Then what we're going to do is we're going to take this absolute value function. So for zone 1, which have values for x less than 2, we're going to plug in values that are within this zone. So we're going to pick something that's less than 2. Let's pick 0. So if we plug 0 into our original equation, we're going to have the absolute value of 3 times 0 minus 6. That's going to be 0 minus 6 minus 6 within the absolute value sign, but when we bring it out, it's positive 6. Because the absolute value result and the final result were opposite, we're going to use the opposite form of the equation for this zone. So let's do that right away. Okay, so for zone 1, when x is less than 2, we're going to use the opposite of the original equation. Now we're going to evaluate zone 2. So in zone 2, we're going to pick a value of x which is greater than 2. So let's use x equals 3. So if we plug in x equals 3 into the original equation, we would get 3 times 3 minus 6, 9 minus 6 equals positive 3, absolute value, and the final result after you pull it out of the absolute value is positive 3. Because these match, when we're in zone 2, namely when x is greater than or equal to 2, we are going to use the exact same equation that we were presented with. Now one note, I didn't mention this when I solved it the original way. You only make one of these inclusive. It doesn't matter which one you choose, but you can't choose both. I typically make the greater than inclusive, but that's just my convention. You can do it any way you want. So you see you get the same result by either method. I tend to like to use this method. Greater than or equal to 0, solve for it, and because you set it to a positive result, greater than or equal to 0, you keep the function as is. In part 2, when you set it, here in blue, when you set it less than 0, that's a negative result. For those values of x, you're going to use the opposite form of the original function. Let's look at this second example, and again, I'm going to do it both ways. First, the way I like to do, I'm going to set x plus 5 to a positive value. I'm going to solve for x. X is greater than or equal to negative 5. And since I set this to a positive value, namely greater than or equal to 0, I'm going to use this exact function when x is greater than or equal to 5. So let's go ahead and build our piecewise function. So when x is greater than or equal to negative 5, I'm going to simply use x plus 5. Now I'm going to do the opposite. I'm going to set x plus 5 to a negative number, which is less than 0. I'm going to solve for x. So here, when x is less than negative 5, because I set this to a negative number, the final result is going to be opposite to that, because the final result is always positive. So I'm going to use the opposite of the original function. In math, the minus sign is translated to the opposite. So again, I only used one of these inequalities as inclusive, and I like to use the greater than or equal to. Now let's do it the other way, which again your teacher might prefer, and that is to set things equal to 0, establish that dividing point, and then examine both sides of that dividing point. So let's do that. And I think this is going to be the last time I'm going to do the second method. Okay, so we're going to set x plus 5 equal to 0, x equals negative 5. Okay, we're going to put negative 5 on a number line, and we're going to have two zones, zone 1 and zone 2. Okay, let's examine zone 1 when x is less than negative 5. So I'm going to plug in for zone 1, x is less than negative 5. I'm going to use negative 6 and plug that in to the original equation. Okay, when I do that, I'm going to get negative 6 plus 5, the absolute value. Absolute value of negative 1 is going to be positive 1. So in this zone, zone 1, we have a value inside the absolute value being opposite to the final result. So for this zone, when x is less than negative 5, I'm going to build my piecewise over here. When x is less than negative 5, we're going to use the opposite of the original function. Now we move to zone 2. Let's plug in 0, which is above negative 5. If we plug in 0 to the original equation, we're going to get the absolute value of 5, which equals positive 5. They match. So for this zone, when x is greater than negative 5, we're going to use the original function exactly as is. Since these match in sign, we're going to keep the function as is for this domain when x is greater than negative 5. That's zone 2, and we picked a value, namely 0, that was within zone 2. In this next example, we're going to ignore this portion right here, or I should say it's just going to come along for the ride. So let's first set this to a positive value. X minus 4 is greater than or equal to 0. X is greater than or equal to 4. So as we build our piecewise function, the first section is going to be x greater than or equal to 4. And we are going to use this exact function exactly as it is because we set it to a positive value. So the first part of the piece of this function, when x is greater than or equal to 4, we're going to have x minus 4 plus 3, which is going to simplify to x minus 1. Okay, next we're going to set the inside of the absolute value to a negative value. Specifically, we're going to set x minus 4 less than 0. X is going to be less than 4. Okay, so down in this portion, x is going to be less than 4, and we are going to use the opposite of this function and then simplify. This is going to be negative x plus 4 plus 3, and your final answer here is going to be negative x plus 7. Okay, let's do another one. Here we have y equals negative in front of 2x plus 6. Okay, we're going to set this to a positive value, greater than or equal to 0. 2x is greater than or equal to negative 6. X is greater than or equal to negative 3. So for this component, x is greater than or equal to negative 3. Now, we're going to use this exact same function because it is a positive value. So we're going to have a negative here, and we're going to use this exact same function. All right, so that final is going to be 2x plus 6 with the minus sign out front. And if you want, you can distribute the negative and get minus 2x minus 6. Either form is acceptable. Okay, next, we're going to set this to a negative value. So we're going to say 2x plus 6 is less than 0. 2x is less than negative 6. X is less than negative 3. So for this component of the function, when x is less than negative 3, we're going to use the opposite of this function. So that negative sign stays out front, and then we're going to use the opposite of what's in the absolute value. So these negatives are going to cancel out, and you're going to end up with just 2x plus 6 as the second piece of this function. If you're unclear as to whether those negatives indeed cancel out, you could first distribute this negative and you'd get negative 2x minus 6, and then you would redistribute the second negative and you would get 2x plus 6. Let's go ahead and rewrite this absolute value equation in a piecewise manner. Positive is going to be 5 minus 2x greater than or equal to 0, and the negative version is going to be 5 minus 2x less than 0. Here, with the positive version, we're going to solve for x. We're going to get negative 2x is greater than or equal to negative 5, we're going to divide both sides by -2 and flip the sign. So we're going to get x is less than 5/2. Here we're going to have -2x is less than -5. Divide both sides by -2. Flip the sign. We're going to get x is greater than 5/2. So for this portion, we're going to use the opposite. Okay, let's go ahead and write our piecewise function. First, when x is less than 5/2 or equal to, okay, that is this portion here, we're going to write it exactly as is, 5 minus 2x. And when x is greater than 5/2, we're going to write the opposite. So if we put a negative in front of this and distribute that negative, either form is okay. Now, let's look at this and graph this. So if we start out with y equals the absolute value of 5 minus 2x, let's see why this makes sense. So if I was to graph the line -2x plus 5, we would have a y-intercept of 5 plus 5. And if we set y equal to 0, we would get a x-intercept of positive 5/2. So we would have a line that extends with a slope of 2, but in the negative direction. But because of this absolute value sign, we would then take any negative portion of this line and reflect it over the x-axis and make it positive. So as we go back and we look at our piecewise function that we have, we see that when x is less than or equal to 5/2, we have the original line, and that fits our graph. Here x is less than or equal to 5/2, and we have our original line. However, for x greater than 5/2, we have this line, which is 2x minus 5. So 2x minus 5 is this portion. And indeed, if you extended this, you would see that that would have a y-intercept of -5 and a slope of +2. This next problem is a quadratic equation, meaning it's going to be a parabola. So in this case, folks, we will use the technique of finding the zeros. So let's go ahead and factor this. We're going to have x minus 5 and x plus 2. And if we set that equal to 0, our zeros are going to be positive 5 as well as -2. So folks, because of this positive coefficient in front of the x squared, we know this is an upright parabola, which is going to cross the x-axis at -2 as well as positive 5. So it's going to be doing something like this. Now, we don't really need to know where the vertex is. It could be anywhere, but we don't need that. But what we do notice is that in this region here, when x is less than -2, we have this function as a positive function. Here, between positive 5 and -2, it is negative. And when x is greater than positive 5, we have a positive function. So we're going to use that to our advantage. Let's go ahead and build our piecewise function right away. Okay, so for x less than or equal to -2 or x greater than or equal to positive 5, our function is going to be positive. Therefore, we're going to rewrite the function exactly as is. For this region, when x is between 5 and -2, because this portion of the graph will be negative, we're going to use the opposite of the original function. And that is our piecewise function. Now, in case this graph doesn't occur to you, I'm going to show you how to do this algebraically. All right, we're going to keep our factored form, and we're going to keep the concept of using zeros, but we're going to consider these zeros as points of interest. Let me show you what I mean by that. We're going to build a little number line and we're going to create zones similar to how we did in the first couple of problems in this video. So here's our number line, and we're going to have the zeros. Recall the zeros are going to be +5 and -2. These are the x values that make the entire function 0. How do we get that? We set each of these factors equal to 0. So if we set x minus 5 equal to 0, we get x equals 5. And we do the same thing with the other factor. Okay, let's build our zones here. So we have -2 here. We have +5 here. Let's put some lines in here. So this is zone 1, this is zone 2, and this is zone 3. Let's go ahead and examine zone 1. In zone 1, the x value is going to be less than -2. Now, when we plug in, folks, we don't need to know the exact values. All we need to know is if we're going to get a positive value or a negative value, and that'll tell us if the whole function is positive or negative. So for zone 1, I'm going to use -3. If I plug in -3 here for x, I'm going to get -3 minus 5. That's a negative value. And if I plug in -3 here, I'm going to get another negative value. So because I got a negative and a negative, and the number of negatives is even, the function's going to be positive. So I'm going to put positive here. In zone 2, I'm going to choose a number between -2 and +5. I'm going to choose 0. If I plug in 0 for x, another way to do that is just to put my finger over the x to eliminate it. We see we have a negative value in the first factor. And if I put a 0 here by covering the x with my finger, we're going to have a positive value. Because the number of negative signs is odd, we're going to get a negative total result for the function. And finally, in zone 3, let me put a negative there in zone 2. And finally, for zone 3, we're going to pick a number greater than 5. I'm going to use 6. If we plug in 6 here in the first factor, we get a positive value. Plug in 6 here, we get another positive value. So that is going to be positive. So folks, in these two zones, we're going to get a positive result. Therefore, we're going to have our function exactly as is. Okay, so this is going to be for zone 1 and zone 3. And then in zone 2, which is the only portion of the graph which was negative, we're going to get the opposite of the function. So this would be zone 2. Folks, I want to point out something from the last problem we just finished, where we had our 3 zones, and I didn't go ahead and write out this completely, so I just wanted to do that. So zone 1 and zone 3 are both going to be positive, and therefore we're going to have the function exactly as is. So notice when I set x is less than or equal to -2 to depict zone 1, and then x greater than or equal to +5 to depict zone 3, I use the inclusive version of the inequality. However, when x is between those two zones, when we're negative, I just use the non-inclusive form of the inequality. So I think this is a good way to do it, to keep them straight so you won't double up on that border. So -2 is a border number for zone 1 and 2, as is 5 for zones 2 and 3. So you just have to make sure that at the border of 5, 1 is greater than or equal and 1 is just a less than, and the same thing with the border number of -2. This next example features another quadratic equation. We're going to go ahead and factor out the x, and we're going to get x minus 5 as our 2 factors. We're going to set each of these equal to 0, and we're going to end up with these 2 values of x that are our zeros. Now if we look at this, folks, we note that this is a parabola. We know that it is opening up because the coefficient in front of the x squared is positive. So here we're going to have something like this. Again, we don't know where the vertex is, and we really don't need to know. All we need to know that our graph is going to look like this. So this region is going to be positive, this region is going to be negative, this region is also going to be positive. We could write this in 2 seconds. Here's the original version of the graph. That is when x is less than or equal to 0, or x is greater than or equal to positive 5. And then we're going to have the opposite version of the function when the inside of the absolute value is negative, and that's going to be between 5 and 0. And again, I made these inclusive and this non-inclusive. But again, in case you're not sure how to work the graph of the parabola into this, let's go ahead and do the algebra. We're going to factor again. We're going to get our two zeros, otherwise known as points of interest, as 0 and positive 5. Folks, this is going to create 3 zones that we're going to examine individually. We're going to pick values within each of these zones and plug them into the equation. Okay, so for zone 1, let's choose -1. If we plug in -1 here, this factor is going to be negative, as is this one. When you have an even number of negatives, when you're examining, the whole function's going to be positive, and that matches what we have on our graph. For zone 2, we're going to pick something between 0 and 5. We're going to pick +1. When we plug that in here, we get a positive value and a negative value. Because the number of negative values during this examination process is odd, the whole function's going to be odd. Finally, in zone 3, let's choose +10. This is going to be positive, that's going to be positive. The whole function will be positive, and we have a matching of our little graph. So for the positive portions, we're going to use exactly what we see. And for the negative portion, we're going to use the opposite of what we see. In this next example, we're going to factor and create our zones. So we're going to pull out an x. We'll have x squared minus 2x minus 8. And then we'll factor again, and we'll have x minus 4, x plus 2. So our zeros are going to be at 0, at +4, and at -2. Here, folks, we're going to have 4 zones. Okay, let's examine each one of them. In zone 1, I'm going to use, to plug in, I'm going to use -3. So the first factor will be negative, the second factor will be negative, and the third factor will be negative. Because the total number of negatives is odd, this entire zone will be negative. Here in zone 2, I'm going to use -1. Plugging in there would give me negative. This is a negative, and the last one is positive. That's going to end up with a positive total because that's an even number of negative signs. Here in zone 3, I'm going to use 1. So we're going to have a positive, a negative, and a positive. That whole function then will be negative. And finally here I'm going to use x equals 10. That's going to be positive, positive, and positive. Okay, folks, so for zones 1 and 3, we're going to use the opposite function, and for zones 2 and 4, we're going to use the function as is. So here's the function as is, the original. We're going to see that in zones 2 and 4. Zone 2, x is less than 0 and greater than -2. Zone 4 is x is greater than or equal to 4. The other part, you're going to use the opposite function. wherever we get a negative. So that is going to be zones 1 and 3. Zone 1 is when x is less than or equal to -2, and zone 3 is going to be when x is between 4 and 0. Let's do one last example of rewriting this function as a piecewise function. So we're just going to treat this like we're graphing a rational function. And recall, when we do a rational function graph, we look for points of interest. So the first thing we notice is that x cannot equal 1. Cannot equal -1. It's restricted. And we have a vertical asymptote at x equals -1. The second thing we notice is that we have a 0 at x equals +3. So we're going to look at our points of interest, and we're going to evaluate this function in our zones. So even though x is not allowed to equal -1, it's still a point of interest. So we're going to call these zones 1, 2, and 3 respectively. And let's look at zone 1. We're going to ignore the 3 when we're evaluating the sign. It doesn't play a role in the sign. Excuse me. A -3 would, but not a +3. Okay, so here we are in zone 1. Let's use -2 and plug that in. If we plug in -2 to the numerator, we're going to get a negative in the numerator, and a -2 will give us a negative in the denominator, so the entire fraction would end up positive. In zone 2, we're going to use 0. When we use 0, we put our thumb, or in this case a cursor, over the x. We're going to get -3 over +1. Again, the value is not important. We're just concerned about the sign. Since there's an odd number of signs, namely only odd number of negative signs, namely only one negative, the entire fraction becomes negative. And in zone 3, we're going to use 5. If you plug in 5, that's going to be positive, and that's going to be positive. So our function's going to be positive. So we're going to have positive, negative, positive. Now, we have to be careful about this restriction where x cannot equal -1. So as we build our function, piecewise function, we're going to leave the function exactly as is in the regions where we have a positive value. So that's going to be zones 1 and zone 3. Now, for zone 1, it's going to be x. Normally we do less than or equal to -1, but here we cannot include this -1 because of the restriction. And then we're going to have x greater than or equal to 3. And we're going to have the opposite of this function. In zone 2, which is when x is less than 3 and greater than -1. Again, we do not make that inclusive. Now, in case you folks are wondering how you would distribute that negative, I always think the easiest thing to do is to change that to a -1. And in math, whenever you have a whole number and a fraction, sometimes it's helpful to change that whole number into a fraction. So here you could see that that negative would distribute to the numerator, but it would leave the denominator alone.